In this lesson, 1-4 properties, our objective today is identify and use properties of addition and multiplication. Use properties of addition and multiplication to simplify algebraic expressions. In order to do that, we have some key terms here in the next couple of slides. The first one is properties, statements that are true for any numbers. And counterexample, an example that shows a conjecture is not true. Our next definition, our key term, is simplify. Means to write algebraic expressions in a simple form. Included in the ability to simplify an algebraic expression is to remember that there are no parentheses or grouping symbols. So we must get rid of the brackets, parentheses, and the division bar. Our last key term is deductive reasoning, the process of using facts, properties, or rules to justify reasoning or reach a valid conclusion. So these are things that you already know, things that you've been taught before, and some of the properties that you will relearn here in this lesson. All right, our key concept, commutative property. We have one for addition and one for multiplication. And what that is basically saying is that we can change the order of our algebraic expressions and it will not change the answers. So commutative is known as order, changing of order. Look at the example and the first one for addition. 2 plus 3 is equal to 3 plus 2. Notice that the order has changed. They're both equal to 5, so the answer is still true. We also could do this for multiplication. 2 times 3 is equal to 3 times 2. Changing the order does not affect our answer. 6 is equal to 6. Our next key concept is the associative property. We have one for addition and we have one for multiplication. The key word here to think of is grouping. All right, grouping. In addition, if you look at our example here, we have in a grouping symbol 5 plus 8. Then we add 2 to it. That's equal to, and notice that the grouping has changed. We have 5 plus the sum of 8 plus 2. No matter what we do with the group, 5 plus 8 or 8 plus 2, our solution is still the same, 15. It does not change our answer. We are allowed to do this also in multiplication. If you look at the example, the product of 4 and 6 times 3 is equal to 4 times the product of 6 and 3. No matter what we do, what grouping symbols, how we group them, the answer is still the same. As you can see, 24 times 3 is 72, and 4 times 18 is 72. So the key word to remember for associative property is grouping. In this slide, we have 3 more key concepts. They're property of numbers. You might be familiar with them, but you did not know they were named. The first one is the additive identity. When 0 is added to any number, the sum is the number. So that means that when adding 0 to any number, like in the examples here, if I add 5 plus 0, it's still 5. Or 0 plus 9 is still 9. And notice that it doesn't matter where the 0 is placed. Whenever adding 0, it does not change the answer. That is the additive identity. We have one for multiplication, multiplicative identity. When any number is multiplied by 1, the product is the number. So you're used to this. Whenever you multiply 1, the answer never changes. Example is right here, 7 times 1 is 7, 1 times 6 is 6. And it doesn't matter whether the 1 is in the front or in the back, when multiplying, it does not change that number. And the last one you might be familiar with, but did not know its name, multiplicative property of 0. When any number is multiplied 0, the product is 0. And you do know that any number times 0 is 0. And it doesn't matter where we place the 0, whether it's in the back, 4 times 0 is 0, or if it's in the front, 0 times 2 is 0. So there you go. Those are 3 concepts besides the commutative and the associative to remember. In this slide, it states, name the property shown by each statement. In problem A, 3 plus 7 plus 9 is equal to 7 plus 3 plus 9. I have to figure out which property of the 5 that were just mentioned in the previous slides fits this type of problem. Well, I look here and I see that 3 is first, but I notice 3 is second in the other half of the algebraic expression, and I notice that 7 has moved to the first place. This to me reminds me of order, and the only property that deals with order is the commutative property, and I will abbreviate because I like abbreviating. And there you go, ladies and gentlemen, that is the answer, because the order has changed in this statement. In this slide, the directions are still the same. Name the property shown by each statement. Problem B has the product of A and 6 times 5 is equal to A times the product of 6 times 5. As you can clearly see, we have some grouping symbols, and these grouping symbols have changed. The grouping has changed. So grouping, of course, is the key word to look at, grouping. And whenever you think of grouping, you think of associative. And for the associative, I'm going to use this longer abbreviation so I don't spell a bad word. There you go. Here we have the same directions again. I have to figure out which property it is. I notice that we are multiplying by 0, and that's a key. So that is, for us, ladies and gentlemen, the multiplicative, and I like to abbreviate, property of 0. And to remind you what that is, anytime you multiply by 0, the answer is 0. And that's the name of the property. This is asking us to use mental math. In order to use mental math, we have to use some of the properties that we just learned. I see that 25 times 11 could be a bit difficult, but I am allowed to, multiplying is to group differently, and I'm going to group, or change my grouping, so it's easier to work with. 4 times 25 to me is 100, and I can multiply it by 11. Well, we know that we can take 1 and 11, we get 11, add 2 zeros, and there's my mental math. So we are using properties to rearrange our problems, our equations, our sentences, so it's easier to work with. If you remember from the first couple of slides, we had counterexample and deductive reasoning. I'm going to use my deductive reasoning to see if this statement is true or false, and if it is false, I have to provide a counterexample. So once again, I'm going to read the statement and see if it's true or false. If it's false, I provide a counterexample. So I'm going to use my deductive reasoning. Subtraction of whole numbers is associative. I do remember that it was for addition and multiplication, the associative property. I don't remember subtraction. So can I build a counterexample that proves this statement false? Let's see here. 9 minus, and associative is grouping. I'm going to make a group here, and I'm going to go 9 minus 5 minus 3 in the group. And I'm going to make the statement equal to, and I'm going to change the group here, 9 minus 5 minus 3. Alright, so I'm going to now work out the problems according to PEMDAS. So I have 9 minus 2, and 9 minus 2 is 7. Is that true to the statement on the other side of this equation? 9 minus 4, or 9 minus 5, sorry, is 4 minus 3, and that is 1. Is this a true statement? No. So therefore, I provided a counterexample, and the statement above, subtraction of whole numbers is associative, is false. So notice I provided a proof, and there's my answer. In this slide, it asks us to simplify the expression. Problem A is the sum of k and 2 plus 7. Well, I cannot do inside the parentheses according to PEMDAS because k is a variable. I could add 2 and 7. And because this is a grouping problem and it's addition, I'm allowed to use the associative property to move, and I'm going to write associative so you know what I am doing. So I'm going to move the group. I am going to group what's alike. As you can see here, I am now going to do inside the parentheses. Well, 2 plus 7 is 9. And I got rid of the parentheses. I cannot add 9 and k. Therefore, it's simplified. Same directions in this slide. We've got to simplify the expression that you see in problem B. 5 times the product of D and 9. Well, I noticed that inside the parentheses, according to PEMDAS, I can't really do this right now, d times 9, because d is a variable. If I switch the order of multiplication, I might be able to do something. And when I switch order, it's a commutative property. So you'll see that I'll just switch the order. I'll have 5 times 9 times d. I will group them, the like terms, together. 5 times 9 is 45 times d. Now I'll just simplify or clean up this equation, and there you go. So I changed the order, which is commutative. I grouped the like terms together, which is associative, and I came up with a simplified expression of 45 times d, or 45d.